Hello, I am here today to talk about biomolecules. So, biomolecules are very important for all life, but especially important for humans. There are four types of biomolecules, which are carbohydrates, lipids, proteins, and nucleic acids. All four of these are very important for humans, and basically, I'm going to be explaining what they are and why they are important for humans. Now, you've probably heard of two of those terms I just mentioned, carbohydrates and proteins, but you probably have not heard of the terms lipids or nucleic acids. But you probably have heard of them. They also go by fats and DNA and RNA. So basically, lipids are just fats, and nucleic acids are DNA and RNA. You may not have heard of RNA, I'll get to that a bit later, but you probably have heard of DNA if you've ever watched an X-Men film. They've got like a whole monologue at the beginning about DNA, and like all of them. So first off, I should mention there are monomers and polymers, which are important terms. Basically, monomers are the building blocks for all of these biomolecules. And polymers are a whole bunch of those building blocks all stuck together to form a larger item. Uh, so that's pretty much the important part of it is monomers are the small bits that are the building blocks, and polymers are those building blocks all stuck together. First off is carbohydrates. Carbohydrates is the first biomolecule. Carbohydrates are good for short-term energy. So basically, you need to outrun a pack of wolves, you're going to want carbohydrates. You're probably never going to be in that situation, at least hopefully. But if you are, carbohydrates are what you're going to want to use. The monomers for carbohydrates are called monosaccharides, and the polymers are called polysaccharides. So pretty simple. It's just saccharide and then mono or poly at the beginning, depending on which kind you're talking about. Sorry by the way for the shaky camera. I'm just recording this on my phone and I'm holding my phone with my hand, so the video is gonna be a bit shaky. But on to the second one. So the second one are lipids. Lipids are probably the most unique out of the four, just because there's a few properties about them that are different from the other three. So lipids, like I said, are fats, and most people wouldn't see why fats are useful, right? Most people think fats aren't very useful, but lipids are actually useful for long-term energy. They're not good in excess like any of the other three, but they are good for long-term energy. So carbohydrates, short-term energy, and lipids are long-term energy. Now, I said they're unique from the other ones. There's a couple reasons for that. For one, lipids do not have true monomers or polymers like the other three. And the other reason is that they're hydrophobic. Hydrophobic basically means it doesn't mix well with water. So like if you've ever tried pouring some oil into a bowl of water, it doesn't mix together, it just sort of stays separate. That's because the oil is a lipid and is therefore hydrophobic. The other three are hydrophilic, which means they do mix with water. That's something that applies to all lipids, by the way. All of them are hydrophobic. The next one is proteins. Now, you've probably heard of proteins in relation to muscle building. And that's true, they are important for muscle building. But they are also important for a variety of other functions, such as your immune system. So, proteins are very important, and generally, if you are on a vegan or vegetarian diet, you need to take protein supplements because protein is important, and generally those diets don't give you enough protein since protein is mainly found in meat. It's also found in a few other things like nuts, but most people get their protein from meat. And the fourth and final biomolecule. 1 minute. The fourth and final biomolecule are nucleic acids. And I mentioned already that is DNA and RNA. Now, DNA is basically like your genes. It's sort of like the blueprint for your body, right? DNA says how to build certain things in your body. It's information storage, basically, right? RNA is kind of similar, but a bit different. RNA is more of the tools used to create the actual parts of your body rather than just the blueprints. So DNA has the blueprints of how to create things like proteins, and RNA comes in and looks at the blueprints and then creates those things. So that's basically what DNA does and what RNA does. The reason they're called DNA and RNA is based on the sugar they use. They use the same sugar basically, just DNA, it has one less oxygen. RNA uses the sugar, ribose sugar, and DNA uses deoxyribose sugar. It's called that because it's deoxyribose. Ribose without one of the oxygen, basically. And that is why RNA is called RNA and DNA is called DNA. Anyway, so those are the 4 biomolecules. Those are why they're important. They're important to all life, especially humans. And you definitely don't want to be low on any of them. However, like I mentioned, a lot of them can also be very bad in excess. So basically just make sure you're getting the right amount of each. That's it.